Section 9.3 is on page 533, talks about geometric sequences. In a geometric sequence, the ratio of consecutive terms are all equal to a common ratio R. Alright, so geometric series, sequence I should say, or series is coming up. You find a sub 1. To get to the next term, you multiply by R. I did the same mistake as last time, right? At least I'm consistent even in my mistakes. So, to get from this to that, you multiply by a number, they call it R. So to go from any term to the next, you multiply by this number, and it's fixed, it doesn't change. Right? So, the reason they call it R, to find what R is, take any term you want, divide it by the previous term, and that's where the word ratio comes in. So, A1 is given, that's the first term on the list. A2, to get A2 you take A1 and you multiply it by R. To get A3, you take the previous term, which is, and you multiply it by R. To get A sub 4, you take the previous term, which is A1R squared, and you multiply it by R, that's A sub 1 R sub 3. And if the list goes on, A sub n, well, you notice all the terms, what they have in common, A sub 1 is common in all of those. And R is common in all of those. The only variation is the power. It seems if this is 2, there's an R to the 1. If this is 3, there's an R squared. If this is 4, this is 3. Whatever this is, that power is 1 less, and that's how they come up with this general term, which is a key for us to solve anything using geometric series, just like arithmetic. Now that you've seen arithmetic, this should be smoother, I hope. So it says find the indicated term of a geometric sequence. They give us A sub 1 and A sub 2. Now a general term of a geometric sequence is really A sub n equal A sub 1 times R to the n minus 1. What I need to know what A sub 1 is, and I need to know what R is. Notice here they gave us A sub 1. So half of the problem is solved. So we know that A sub n is a 3, but I still need to know what R is, plug it in, and I'm done. And what do you notice here they say? They say A sub 2 is 9. So two ways of doing that. Either you say A sub 2 is A sub 1 times R to the 1, and that equal 9, but I know A sub 1 is a 3. So in this case, R equal a 3. And there it is. Let n equal 1, you get 0 power. 3 times 1 is 3. If you let n equal 2, that becomes a 1. 3 times 3 is 9, and that's how the list goes off. This is the best way to figure it out. You could say, but look, that's 9, 3 and 9. Just take any term divided by the previous term. But in the event that they don't give you consecutive terms, this formula solves all. Alright. I'd like to look at the next set of problems. Find the general function for each geometric series. Again, we're always doing that. And this is the example I was mentioning. So to find the general term, I know that A sub n is A sub 1 times R raised to the n minus 1. Or here, let me write it here. So A sub n is, I need the first term, I need R raised to the n minus 1. Now I could simplify, by the way, I could say this is 3 to the 1. If you multiply those, you write the single base and you add 1 plus n minus 1 is n. You really don't have to. This is a fine answer as is. Here, the goal is to find a sub 1 and r. Well, this is what they told me. I'm looking for two things, two values, and they gave me two equations. They said a sub 5. Isn't a sub 5 a sub 1 times r to the fourth? And a sub 9, isn't a sub 9 a sub 1 times r to the 8? But a sub 5 equals a 2. And a sub 9 equals a 1/8. Two equations, two unknowns. I could do this a couple of different ways. I could solve this equation for, say, a sub 1, and say a sub 1 is 2 divided by r to the fourth, and use substitution. Put that right there. That will make a sub 9, that will make 2 divided by r to the fourth times r to the fourth equals 1/8. And you know what I mean, r to the 8th. This divides 4 of those, right? Cancels 4 of those. And if you divide by 2 both sides, this is saying that r to the fourth equal 1 over 16, and that would mean that r will equal plus or minus 1/2. Let's see how it works. A sub 1 will be 2 divided by, if I take plus or minus 1/2 and raise it to the fourth power, that is 2 divided by 1 over 16, that's 32. So we figured out that the first term is 32, and we just figured out that r could be a plus or minus 1/2. There's no way of figuring that out, because by the time you get to the 9, it's going to be positive anyways, and a sub 5 is going to be positive. There's no way of telling. So you would say the general term could be either the first or the second. So it could be any of those two. What is that? Okay. Now the sum formula, if I want to take the sum of the first n terms, that turns out to be the first term into 1 minus r to the n divided by 1 minus r. Now, this sum formula I provide on the exam. Similarly, I will provide the sum formula for arithmetic sequence. But geometric has two sums. It has a finite sum. This is adding the first n terms. And this is referred to in most books as S sub infinity. If you add an infinite amount of terms, if the absolute value of r is less than 1, meaning if r is between -1 and 1, then this infinite sum will be the very first term divided by 1 minus r. So when I look at problems number 5 and 6, it says find the indicated sum of each geometric sequence. The first 6 terms, they want us to find S sub 6 based on this formula that I'm going to provide. That's the first term into 1 minus r to the n divided by 1 minus r. And you notice, to find the general term, I need the first term, and I need r. And that's pretty much what you need for all of those. So, since you're looking for S sub 6, you want that to be raised to the 6th power. So the way it works, they gave us a sub 1. And they gave us r. So in this case, S sub 6 will be 2 into 1 minus 3 1 minus 3 raised to the 6 divided by 1 minus 3. Now, this is a fine answer unless you are allowed a calculator on the exam. You could just plug it in, and you plug it in exactly as you see it. 2 parentheses 1 minus 3 raised to the 6 divided by 1 minus 3. You could do that by hand. 728. If you add the first 6 terms of an arithmetic sequence that starts with 2, then you multiply by 3. So 2, 6, 18, 18 times 3, that will be 728. You'll figure this out quickly. Since you're multiplying, geometric series either expands very quickly or decay very quickly. Find the sum of the infinite. If they say infinite, you're looking at this. And it says the sum of infinite geometric sequences, but absolute value of r has to be between -1 and 1. And they gave us both. Again, here we're saying s is going to equal, by not writing anything, you're saying this is the infinite sum. That is summing n equal 1 to infinity a sub n. That is the very first term divided by 1 minus r, provided absolute value of r is less than 1. So here, there's r, and it is less than 1, right? So absolute value of 3/5 is less than 1. It checks. So s sub infinity, if you add all of these terms, you're going to get the very first term. The very first term is given. And if it wasn't given, we can find it. Divide it by 1 minus r. And if you work this out, this is actually 300 divided by, so this is a complex fraction, if you really think about it. 1500 over 5 minus 3, and that turns out to be 750. You could plug that in the calculator. So if I start adding 300 plus, if I multiply by 3/5, 5 divides 300 60 times 3 is 180, plus divided by 5 times 3, plus, if you add all of these infinite terms, you'll get 750. If you get your calculator out and add the first 20 terms, probably you get 749.5. You will never reach this unless you take this far enough. And this is, again, the key in you figuring out which of those two formulas to use. Is it finite or infinite? This is infinite. And only geometric series has an infinite sum. So first I need to figure out, well, a sub 1 is 300. That's easy. That's given. I need to figure out r. Take any term divided by the previous term. And if I throw this in, 225 divided by 300. That is 3/4. In absolute value, that's less than 1. So I know that this infinite sum, equals the very first term divided by 1 minus r. What's the first term on the list? 300. Divided by 1 minus, and r is 3/4. Again, a complex fraction. This is over 1 over 1. LCD is 4. That's 1200 divided by 4 minus 3. That is going to be 1200. And if I get my calculator out and start with 300, add to that 225, add to that 168.75, add to that 126.5625, add to that 94.921875. I'm at 915. I have to add about 20 or 30 terms until I get very close to 1200. And to really get to the 1200, I have to take probably about a few hundred terms. And here it is again. They give you that in a lot of different formats. Same deal. I'm glancing at this, and again, you're adding an infinite sum. You need to get r. If you're not sure how to find it by looking at this, list 2 or 3 terms. Let n equal 1. Wouldn't that be 2 over 5 to the 0, which is 2? Let n equal 2. Isn't that 2 over 5? Right? The list goes on. But isn't the first term a 2? And how do you find r? Isn't r any term divided by the previous term? and instead of dividing by a fraction, you multiply by the conjugate. So r is 1/5, which is an absolute value less than 1. So this infinite sum will equal the very first term divided by 1 minus r. That is, the very first term, which is a 2, divided by 1 minus r is 1/5, complex fraction again. That is 10 over 5 minus 1. That would be 10 over 4, which is 5/2. This infinite sum will be 2.5. And again, you could list a few terms. Luckily, the weekend is around the corner. And with COVID and all, you have nothing to do. You could play with this at home instead of being bored. And see how that goes. Add the first 20 or 30 terms, see what happens. Here's a repeated decimal. Write each repeating decimal as a fraction in simplest form. Isn't this, so here, isn't that 0.42 plus 0.0042 plus 0.000042? Think about it. If I add those, isn't that what this is? So isn't this 0.42 plus 0.0042 plus 0.000042? Isn't this 42 over 100 plus 42 over 10,000 plus 42 over a million? Isn't that geometric? And if I write it, if you still don't see it, isn't that 42 over 10 squared plus 42 over 10 to the 4th plus 42 over 10 to the 6th? And wouldn't you say, out of those, a sub 1 is 42 over 10 squared? And isn't r take, look at it this way, what did you multiply to get from this to this? Isn't that 1 over 10 squared or 1 over 100? That's less than 1. So I could take this sum and I could say that's the very first term, which is 42 over 10 squared divided by 1 minus r. Right? And what would that be? 10 squared is the LCD, so this has it. That's 42 over 100 minus 1 is 99. That simplifies because 42 divisible by 3. 3 divides that, 3 divides 1 14 times, and 3 divides 33. And if I get my calculator out, and if I take 14 divided by 33, 0. Again, my calculator, that means 0.42424242. I could show you that better with, oops, what happened? With this calculator, if I take 14 and I divide that by 33, and there it is. Cool trick, don't you think? And let's do one more. Find the sum of the first, find the 30th term of a geometric sequence. They're given us a geometric sequence, which means a sub n is a sub 1 times r raised to the n minus 1. A sub 3 is 10. So, a sub n is going to equal, I need the first term, I need r, and I'm done. I need a sub 1, I need r. Well, let's see. A sub 3 is a sub 1 times r squared, and that is 40. A sub 10 is a sub 1 times r to the 9th, and that is negative 5120. system of equations. That's like saying xy squared equal 40 and xy to the 9 equal negative 5, 5120. I'm going to use substitution. Again, you could solve by using elimination, but since we're so used to substitution, I'm going to solve for a sub 1. Isn't a sub 1 backwards? Isn't that 40 divided by r squared? And I'm going to take this and substitute that right there for a sub 1. So this equation would read 40 divided by r squared times r to the 9 equal negative 5120. This cancels two of those. So r to the 7 equal, and if I get my calculator out, and I take 5120 divided by 40, that's 128. And wouldn't r equal the 7th root of negative 128? And what is that? If I raise that to the, where is it here? 1 divided by 7. I'll get a 2, or negative 2. I got r to be negative 2. Plug it in. If I take the negative 2 and I plug it in, doesn't that mean that a sub 1 is 40 over negative 2 squared, which is a 4? Isn't that a 10? So I got a sub 1 to be a 10, and I got r to be a negative 2, and there it is. 10, negative 2, and that's my answer. The homework on this, 1 through 15 odd, and 11 through 15 all. Page 516.